When we think about solving absolute value equations, we first need to think about relative value versus absolute value. Those of you who were in 6th grade in our school remember Miss Fallon, who is very tall. Now, compared to Miss Fallon, or relative to her, I am short. On the other hand, if you remember Miss Kenna from the 6th grade, I'm actually pretty tall relative to her. In the context of these sentences, relative means compared to. On the other hand, absolute pretty much means exact. So it doesn't matter if I'm standing next to Miss Fallon or Miss Kenna. My absolute height is still 5 foot, 5 inches tall, no matter what. And it's the same thing with numbers. When I think about the number 3 and the number -3, I can see that relative to 0, +3 is 3 units to the right. So relative would mean compared to 0, 3 is to the right, whereas -3 is 3 units to the left of 0. Absolute, however, is an exact value, which means that both 3 and -3 are exactly 3 units away from 0. So if you were thinking about finding two values to make this particular equation true, you might decide that x equals 3 and x equals -3 are the two best values that we can find. But absolute value equations are usually a little more complex than this. For instance, if I have the equation, the absolute value of x plus 1 is equal to 3, I need to readjust my thinking slightly. One student in class today came up with the solution that x could be 2, but x could also be -4. So if we think about where is the line of symmetry in this particular situation, we would see that it's been moved down to x equals -1. And x equals -4 is exactly 3 units away from that, and x equals 2 is 3 units away from that as well. On the other hand, if I think of the absolute value of x minus 1 is equal to 3, then another student said that in this case x is +4 and -2. So now the line of symmetry, or the starting point, starts at x equals 1. And 4 is 3 units from that, and 3 units away from -2 as well. So we have to have some kind of shortcut, and in this case algebra is actually the shortcut. So I'm going to be looking inside the absolute value symbols to the expression that's there, and I know I'm going to want to set that whole expression equal to -3 or 3. So let's take a look at this equation. The absolute value of x plus 1 is equal to 3. I still want this expression that's inside the absolute value sign to be equal to either -3 or +3, because I know that the absolute value of -3 is 3 and the absolute value of 3 is also 3. So I would write two separate equations. X plus 1 could be 3, or x plus 1 could possibly be -3. So when I solve this, I will get the correct solutions of x equals -4 and x equals 2. If we try this equation, then we know the same thing happens. We're going to look at the expression inside of the absolute value symbol, and we're going to say that it must either be equal to -3 or +3, and so we'll set those equations up. In this case, x can either be -2 or +4. I can work on a more complicated absolute value equation that may not be as intuitive to figure out without algebra. In this case, I'm going to solve such that I isolate the absolute value symbol on one side of the equals by first adding 5, dividing by 2, and now I'm ready to set up my two separate equations. X minus 1 can either be 1 or x minus 1 can be -1. Solving, we find that the solution is x is equal to 2 or x is equal to 0. So in summary, we have three things to concern ourselves when solving absolute value equations. First, we need to change or transform the equation such that the absolute value symbol is isolated to the left or the right of the equals. It's by itself. Next, we need to check whether or not the absolute value expression could possibly be equal to a negative number. If it's set up their way, then there is no solution, because that is contrary to the definition of absolute value. Thirdly, the expression inside the absolute value symbols can either be positive or negative, so we should be solving for both solutions.